Setback, minor setback. Back, y'all. I'm sorry about that drop off. The inevitable happens. That just goes to show I have too much processing going on for this processor that I have. Um, we working on it. In a couple days, I'll be getting my new processor in, so I'll be able to run all this stuff and not worry about crashes happening. So random. Took a little minute to get us back up, but we are up. We are back. The actual Creality screen is not populating the camera, so I'm using the secondary camera. Yeah, I can see what's going on inside of the screen, inside of the machine. It's gonna take a while for that print. We're looking at about an hour and 30 minutes of that print. Let me know if whatever y'all want to see or whatever y'all want to talk about. Um, we can move over that way and talk about it or think about it. Ask some questions, answer some questions, whatever y'all up for. Um, the goal here, if you're new and you wasn't in the first live that I did, was that this mount that I have for my differential, I went a little too skimpy on it, so um as we're turning our axle and depending on the ride height of the suspension, we're getting a little flex inside of here, and that's causing some issues with it binding up on the turns. So um, we kind of shifted directions. This the first live was supposed to be about just the steering, and now it has went from just being the steering to us correcting this issue with the differential bracket. So this is what it looks like at the bottom for where we are now. this design has come a long way. This mount was done on the it was designed on live yesterday. So if you missed that live, you can actually go back and see me designing that part yesterday and printing it out and getting it put in today. But right now, that part, so that bracket that we created for for the steering servo is successful, and nothing is binding on. None of the bolts are binding or hitting anything that it shouldn't. Now it's just a matter of having this to be sturdy when we're actuating our ride height and stuff like that. So, and also I know that this is will probably flex once we start driving and this the drive shaft starts spinning as well. So these are like small things that we're tackling on live, and I just kind of wanted to have it to where you all could see me actually getting busy with this build and not just you seeing the my slow roll, and the shorts that's going on. Because the shorts are cool. It's cool doing shorts, but the average person doesn't get to see the full action of what's really happening behind the scenes, all of the hiccups and small things that have to be corrected inside of just creating one video or having one topic going on. But right now, like I said, we got two different topics going on at one time. We had the steering servo, and then now we have uh, the differential bracket. So two different things going on at the same time. One thing's printing to correct one thing, and then we've completed one portion, and we can't fully. Now we're at that part where we can't fully analyze the fix that we did because now we're fixing something that's connected to that fix. And so that's a constant thing too with designing is you fix one thing and then you find out that another thing cannot support what you did to fix the first thing, and so you just kind of go in this circle of fixing and prepping and redoing, moving things around, and finding the best way to put things. But it's kind of like a storm. It'll calm down eventually, and you'll get to a place where it's uh it's manageable, and you're seeing the work pay off. You're seeing everything that you're doing. It's starting to make sense, and it's starting to come together. But I also had a moment today to start redesigning the battery case because my the next topic after the steering is going to be getting the ESC position somewhere. Now I think I narrowed down the position already on where I want this thing at. But I wanted to be closer to the center of gravity, so I'm gonna kind of tuck it away under here on the side. So it'll be tucked away on the side. But initially, I was looking to put it back here in the back. Um, that was one of the options I was playing around with. But then I realized that if I were to put that there, that it would lift my body mount back up, and I wanted that low ride feeling, with the case being on there. We put the case on. Right, so sitting down low like this, you can see the wheel is tucked away inside of that fairing, inside of the wheel well. And it's like that in the front as well. Both tucked away really nice. This is the direction that I want to be. This is where I want to be at with this build. But if I place that the ESC right there is going to lift this body out, and it's not going to allow for that, for the body to sit down in there anymore, and we'll have that gap in there like this. And so it wouldn't be kind of like a low rider sitting low at its lowest point anymore. But that's a big difference. Like from there to have that to be the regular ride height, or the to resting height. It's a big difference to me. So that's something I wanted to keep and maintain. So that's the reason why I decided not to go with putting it inside the battery case. But if I were to redesign this in such a way that my batteries could sit differently, um, I'd probably be the first person to do a ECS, I mean a ESC in the rear of a vehicle. Usually that's a component you find in the center of the vehicle. Um, and I didn't want it up front because, like I said, it like everything, like dealing with these old school cars, the challenge is having that low profile on the front and rear of the vehicles. Like the space that you have to work with here in this trunk area, and the space that I have to work with here along this the hood area, it's very narrow compared to the components that I'm using to for my actuators and the servos and things like that. So when we're dealing with the old school cars, we're kind of really got to get creative and come up with unique ways to keep this thing low. Um, because if we can't get it low, then it just looks like a regular RC car, a regular ride height. And so with lowriders, you want to tuck the wheels into the fairings, you know, have them to tuck behind the wheel wells to give that real lowrider look. And so that was the goal here. And so uh being able to put this thing, and it's pretty bulky, being able to put it back there would have been a challenge. But if if I were to redesign the battery case or the battery pack, which I'm not totally committed to the way I did this battery pack here. Um, but there could be, there's room for improvement on it. But I like how it fits and the weight that it gives the back end. That's why I just kind of kept that design going, and I haven't messed around with it much. Um, but I mean, it's open for discussion. And if you all see some things that would make this build better, shout it out to me. Let me know. I'm open ears. I'm open to different ideas. My knockoffs are all starting to malfunction now. Now that I pointed them out, they're starting to pop off one by one. But that's all part of the learning curve here. Um, Something that would have made these better the rather than having the nuts inside. Like I had the nuts encased in there so they can unscrew like a real knockoff, right, for the wheels. And so what I'm thinking about doing on the next go round is making these inserts to press inside of here rather than do those, because it'll save space with the wall. I can have the wall to be as thick as I need it to be. But also, I mean, that may open up room for me to redesign the wheels for a third time, and open up that center cap a little more and make the knockoffs a little wider as well, so I can have more thickness there. Yeah, with 3D printing, the biggest issue is durability and how the layers are stacked. Um, could either make your part stronger or it can make it weaker. And so we really don't know how weak or strong the part is going to be until you actually get hands on with it. In some cases, like especially if you're new to 3D printing like me, I'm pretty new to 3D printing. So for me, it's a matter of figuring out the best way to position those parts and print them out so that they can have the sturdiness that I'm looking for them to have. But it's hard kind of to look at it in the programs. Like when you see it in the programs, you're not looking at it integrity wise. It's more so of design until you actually get a printout or um, like when I see it inside of the slicer, I get a different perspective of my parts when I'm looking at it in retrospect to looking at what do you call the layers being laid. Hold on, let me give you an example of what I'm talking about. So like this part that we're printing right now, let's see. Bring this camera down just a second. We'll open that camera up and we'll take uh this camera. No, this camera. All right. So over here, you say you've created this part, right? You have this part. You did a great job in it in CAD. You got all your dimensions right. You're ready to print this thing. Now the logic happens, and sometimes you have to get good at thinking about this portion when you're designing in CAD so that this part isn't hard to make a decision about. Having the right orientation of how this thing is printed is going to make a huge difference in how it performs. Like how I'm printing it right now versus printing it upside down the other way, it's going to change the integrity and the durability of this part. Um, I could I could have changed it. I could have orientated it to. Let's see. I could have orientated it to print like this and had supports come out long way to meet the bed that way. I could have did that way. Then the layers would have been stacked, um, going horizontally against these bolts or these screws that I'm going to be using. Now, if I were to print going this direction, I have a possibility. There's a possibility that my layers could separate this direction, and so with it separating, it would be separating right down the middle where the bolts would be, and we want to avoid stuff like that, right? We should never end up with that happening, and so in order to avoid that, we orientate it to where the layers are going to get smashed together when we put the screws in. So these are just things that we think about as we're designing, so that later on when we bring it into a program like this, we're ready to print. We don't make mistakes of printing like this, and sometimes we're orientating these things to try our best not to use supports. But using supports is not a bad thing. It's just a matter of having your setup right so you can uh so your supports could break away easy and not make the surface look rough and jagged and all of that. But the idea is to just when you bring your design into your slicer, to have the right orientation so your layers print and the layers print in such a way that the part is strong. Um, like when I set out to the first design of this when I did the first design of this mount, I printed on that side that I was just orientated at. I printed from this side here, and I didn't have all of this extra stuff added. It was just this block here, and it was the two wings on the sides with the holes to mount. It was very simple. It was straightforward design, but the integrity of it was kind of weak because of the orientation I printed it in. And so my whole goal of how I was printing it in the beginning was just to avoid using up filament on a support. And I'm gonna tell you right now, sometimes it's better to just use the filament and do the support rather than to avoid the support and have a weak part. Um, because you don't want your layers to come loose on you. Um, that'll be the. I mean, you'll end up paying the price for it in the end. If the part breaks, then you have to reprint the whole part rather than just having printed, the part plus a little extra for the supports. But in reference to how much material you're gonna use just to print a support, is really not that much of a difference, and really not that much of a difference for print time as well. Sometimes I get caught up. I used to get caught up in trying to slice to where I'm cutting time. I'm trying to make the best time on a print and stuff like that. And now I'm starting to calm down about it now, and not be so impatient. Um, I'm learning to just allow the printer to do its thing, and uh, find other things that I can work on and tackle while I'm waiting on the print to happen. And so that's just to give you an example of what I mean by having those layers and having the orientation right, just so those layers don't pull apart on you. Now with my knockoffs, um, that was one of those cases where I was not trying not to use the layer, trying not to use uh the supports as well, and orientate it in an up and down fashion. But um that's one of those scenarios where I should have printed that part caddy corner. If I was printing that part caddy corner, um, those layers would have been a lot more durable, and um, it would have been more stronger of a part for how thin it is. Now, if I had a thinner nozzle, like right now I'm using a point 0.4 nozzle, but if I was using a point 0.2 nozzle, uh, those smaller parts would be a lot more stronger, considering a smaller bead of filament for the walls are being stacked. So that's what makes the difference. But if you're working a really small part, you have to have the right orientation, or those layers aren't gonna really last. It'll look good until you start putting strain on it and putting some real pressure on it. But we're here, and we're still not getting our video to populate. And then over here, it's saying that we're on layer 22, in which I think we're further along than layer 22. We've been at it's saying that we've been at it for 16 minutes, but it's been longer than 16 minutes. This thing was printing when I got onto the live stream, and we are streaming 25 minutes right now. So these numbers are wrong. So in actuality, it's telling us that it's going to take an hour or 41 minutes to complete, but it's probably only going to take about 41 more minutes. Creality, get it together on this. I'm looking forward to this thing working and like it did before the update. But it's like when it's trying to do whatever it's doing, it it starts to freeze and cause issues to happen in CAD software, and then hope the whole platform goes down and I lose the stream. And that's not what we're looking for here. We want this to be a smooth environment where everybody's doing good out there, and everybody's able to see what's happening and able to tap in with me and chat and all of that. See the screen if the live is populated yet. So yeah, the live stream is up now. See already, all of the people that were in here watching before the stream went down, it was getting good. It was I was getting some people in here, and you know, I love the dialogue. I love when people come in here and start dialoguing with me. It gives me a sense of direction for how I should be navigating with these things. I believe that this is not populating, and I really wish that it would. Think this new thickness is gonna help a great deal. I think it's gonna help a great deal. I'm happy about that. I'm very happy about that. I just can't wait to get back hands on with it and actually get in here and do it. Let's see though. Let's jump back over to where we were on the bench. Uh, let's take this. We'll drop the bench on top of this so we can have all the information going. The workbench. Pull it down. And it's a joy to have like all of this stuff at my fingertips. I remember at one point in time, um, being able to stream this many things at one time was not like it was not a doable thing. And now we're like in this day and time, we can do whatever we want to do on these streams. It's crazy. All right, now we got this. Let's talk a little bit about this. And if you all are able to type, give me some feedback on what's happening here. The idea is to create a design that people really want to build. This is not just for me, but for the community as well. Things that we want to build or things that we would like to see each other progressing with. Because I think like the market for lowrider RCs it's still out there, but it's not like it used to be. It's not like it was in the 90s. I think like it's kind of like a dying culture unless you live in a place where lowriders are the thing, like LA. But like in other cities, in other states, you're less likely to see a lowrider. I mean, and so that the lowrider scene was my thing as a kid, and I don't have a real lowrider, so the next best thing is to have a RC and to be able to implement all of those great things that we see in those cars and bring it into a toy fashion to where people still learn about the culture of lowridering, you know, and what it means to have a vehicle that sits high or sits low, or to be able to articulate the vehicle in such a way that you're actually speaking a language. The movement of a vehicle and how you set it to the side or the three wheel motion, all of those aspects of lowriders. Um, but to be able to throw all of those ideas from a big scale and bring them down to something very small, to where it's at your fingertips is awesome. And so the goal is to keep it going. Like, don't allow this hobby to die. It's a bunch of people out there that believe that hobbying and crafting is diminishing. It's something that's getting outdated. But and I beg to differ with that. I think that as long as you have people like me, people that love to reconnect with their childhood, man, you're always gonna have somebody doing crafts or RCs or whatever. You're always gonna have somebody that's enthusiastic about something that's cool like this. That's as cool as RCs. But and the goal is to just put your twist on it. Like, what kind of twist would you put on, you know, a RC car, or you know, whatever we're doing here. And so for me, the best of both worlds for me would be a lowrider that I can choose to go crawling with. If I want to crawl with it, I can change the tires out and I can crawl with it. Or if I just want to get fancy and dance around, I can dance around. I can do a little hopping with it, you know. But all together, it shows, the community creativity and how the old school cars, um, how cool it was to have an old school car, how cool it was to be in the era of seeing old school cars driving and the quality of them and the beautification that they do to these vehicles, like when they do the pinstriping and the flakes and all that type of stuff that they add to these vehicles and the sound systems, all of these type of things. um but for me, my twist um is taking an old school car and making it a four-wheel drive. I have dreamed about this for a while now, and I haven't seen it done on a real scale car. um but my goal was to accomplish it in the RC car. And so that's what this is here. This is my Mark 1 of a four-wheel drive lowrider. That is older than 50 years. You feel me? And so we have to get to a place where our the things that we think about aren't just thoughts, but we are able to just create them as well, and bring them to life so other people could see, oh man, that really is cool. Because it might be something that's cool, and you may not know how cool it is until you actually introduce it to people. And people get to see a little portion of it or experience a little portion of it, and they go, man, hey, that's really cool. And then the things that they decide, based on their creativity, that they can bring to the table as well. Yes. Tell him to stop it. So wait for me. Yeah, so when I decided to reach out and start this channel, I have in mind to connect with like-minded individuals like me, that are, maybe you're a beginner in RC world, or maybe you have it together, maybe you're seasoned, but these ideas that we come up with for better ways to have fun, um that's where I'm at with this. Like, this whole thing is, I think, is so cool. And um to throw a four-wheel twist on a lowrider, on a hydraulic lowrider that's fully functional, is it's like it's kind of like a cartoon to me, like a Looney Tune, like in the cartoons when they pull out big mallets out of their pocket, like things that you wouldn't normally expect that would fit in the pocket, that don't really fit in the pocket. but you're just able to pull it out. Just because it's a cartoon, they can make these small things and things happen. um and that's what we're doing with RCs, where I'm trying to push the envelope of creating something that shouldn't exist, or it shouldn't be able to function logically, but somehow I did make it fit and I make it work logically. um because that's what blows people's minds, and whenever you've blown somebody's mind, you're doing something right. You're creating something amazing. If you're able to grab the attention of somebody and go, oh wow, um that doesn't work like that in real life, but you made it work. you know those are the moments there that we live for. So hopefully, we'll see this thing go to a whole nother level. Another thing I need to figure out too is when I ordered the the motor and the ESC. These are two different brands, so the connectors, they don't really fit together how they should. Like there's some space in between these connectors. Um, so I have to work on a scenario where this thing will fit. You know, I haven't cut this shield back yet, but I'm guessing that this fitting here is not the whole fitting, and maybe they just put that inside of there. Well, let's cut it back though. We can cut it back now and see what's underneath. I thought that was a good slice. It felt like a good slice. Slice. Well, I guess any good slice is a slice where you don't cut your fingers up, huh? I had my run-ins with blades from my younger years of doing craft work. I've cut myself up so many times I lost count. I'm a fan of I'm a fan of using Zacto knives, but boy, did I cut myself up good in my earlier years of learning how to use one. I've learned to cut away from my body. That's the bread and butter of cutting with these type of blades, is to cut away from you and away from your fingers. And if you must pry towards yourself, always have a barrier that can catch you if you slip. Because man, I mean, the slippage will happen at the darnest times and mess up the whole vibe for you. So I thought I was right about that connector. Honestly, I was hoping I was right about the connector, but I wasn't. So this is a solid connector. And I was hoping that what they did was installed the cap for the other end on here, but it is one piece. So, um, with that being that way, it's going like I'm going to end up having to break those loose and resolder up my own connectors if I want this thing to be clean. But I don't know if I can find a connector that will fit inside of there. One of these I had already peeled out. I'm really not a fan of how gummy the electric tape gets over time too. It starts off really well, like when you first bring the electric tape out, it's good, and then over time it just gets this gummy feeling to it, and it sticks to everything, and it turns to everything black. I'm not a fan of that. And when I was young, my dad used to have rows of this stuff, and me being a young kid, and maybe this is just with young people. I couldn't stay away from his tape, right? I was always using this man's tape, and he would get upset, and it was like his pet peeve. Like, and for whatever reason, I could not stay away, and I knew that I would ruffle his feathers if I used this tape, but I just had to use it, right? Um, but now I find that my kids are doing the same thing to me, so I guess the it's come around 360. That my kids are using up the tape around the house, and I'm just like, hey, like tape costs money. In so many ways, it was starting to sound like my dad. And but yeah, I really don't understand how come they haven't created a better way to apply the sticky stuff to the black tape. The electric tape it's an amazing tool when you're gonna leave it, but the moment that the heat hits it and that sticky stuff starts to melt, it just gets really messy. What's going on, Francisco? Good to see you in here, man. Right now, I'm just working on the well, I'm working on the bracket for the differential again. So when I designed the bracket for the differential, it was before I designed the differential case. So a lot of other stuff was going on with it, and I thought I can get fancy with it, and I can chop down the meatiness of this and make it more sleek and make room for stuff to fit. Which I thought that I was going to end up putting the servo for the steering up here, which was one of the reasons why I went thin on this thing. But as I install it and I start to work on these other parts and components, I realized that I bit off more than I can chew, um, by taking this thing so thin. And so now it has this flex that causes some binding with the steering. So we're correcting that now. That's what we have on the printer. I've added half-inch thickness to this bracket in both directions to stop that binding from happening, that bending. Um, and then I'm just kind of just talking about what's going on in the RC world, for uh, those that like the lowriders, and for the kids that are coming up today that are growing up without the knowledge of a lowrider or what it is. I live in Hawaii, and there's a few lowriders here, but there isn't a big lowrider scene like there is like in LA or Chicago. You have like huge lowrider scenes. Colorado, another place where you can go and see some really amazing lowriders. Um, but me not having uh uh like a real lowrider car, um, it gives me kind of a setback. So my next best thing is to create one that I can enjoy with my kids still, and that's um that's what brings me down to creating an RC car. But on top of just creating a lowrider RC car is the idea that um, we live in a place where the ground isn't so smooth. It isn't so tailored for the smooth driving. So I wanted this thing to be able to handle well and to be able to maneuver. If they want to drive it on the grass, they could. And so that led me into thinking about a four-wheel drive lowrider where we keep the body of the lowrider, what I'm saying? We keep that old school look, but we throw in four-wheel drive on it. And we keep the ability uh to do the switches, to have this thing bouncing around and have it to where if we need to take it in the grass or on the rocks, we could take it there and we could still do some crawling with it or whatever. But it's got the best of both worlds. You got the cruising and you got the climbing. And so that's what brought me into doing this design. Um I got it to where I can physically show it to people, and then I started this channel so that I can, you know, dialogue with people and see what everybody thought about it, and to allow people to throw in some ideas for when I release these files. Because one thing I want to do, I want to give back to the RC community, and so this is one of the ways that I can give back is to um, share my files with you all, so you can create your own builds based off of this platform. So that's where we're at. So every day I come on here, it'll be me um, either putting together on the overhead view, putting together some parts that we printed out, or going into the CAD work, bringing up Fusion and showing you all exactly how I'm designing the parts. Like I can bring up my Fusion in a second and show you all like what it's taken to create these parts, like all of these parts, and like just take them from your brain and uh create something from it, not just have it to be an idea and think like, oh yeah, that would be cool to have that, but like we're in a day and time where we're old enough to create our parts by ourselves, what I'm saying? Like there's no more waiting for, cars that we want to come out, if you have an idea for them to create a car for to do a certain thing, or you know uh this car could be a drifter, it has independent wheel drive on it. So um I thought about a whole lot of things when I was designing this, and to bring it to you all to kind of just like pick it apart, do what you want to do with it. um which one we want to go into? If we go over to the Fusion, I think I have the Fusion here. Taking forever, but I'm breaking down in here. I come in here and I break down um how I'm designing these parts and the reason why I'm doing certain things. Yep. Yeah, I'll do it tonight. Tonight, not tomorrow. Not right now, but in a little bit. Hey, look, I just have to print it out, but we have something else printing on the bed right now, so we can't print it right now. And well, we gotta wait till that finishes. Yeah, we can do it after that one get done printing. Okay. Yeah, so with that design I was just talking about, this structure, it was this thickness here. I had to go back in and add this whole bottom portion thickness to make this thing back sturdy, and also this direction, looking at it from the bottom side, the thickness of this. so that now we have it to be, it's at a 0.75 now, which is roughly about 3/4 inch, which gives us enough meat for the screw to sit down in there. And then I have an inset for the bolts to sit down in there and be flush on the top. But the the shaft of this portion here, it needs to make contact with the screw in order for it to be a solid fit for the differential. And so I didn't have that before. I didn't have all of that space. No, not that tape, baby girl. The other tape, the blue tape. This one, the clear one. So, and that's exactly what I was talking about. Remember, I was talking about tape. It just hit me up for the tape. Uh, yeah. So I didn't have this full extension here for that screw to make that connection sturdy. So as the lowrider would lift, as we would lift up on this part here, it would push back on the differential, and the differential would move around, and that would cause the steering to bind. Like if the differential, if you see the weakness in how the differential is pushing forward, and you know, we don't need that type of play because it causes the steering to be off. Hold on, Leia. So by fixing that and making that a part more sturdy where this would just stay put. No. Then when the steering starts to move, or when the steering servo pulls, then it's not gonna pull the differential. It's not gonna pull the differential in and make it do all kind of weird stuff. But these are things like when I was designing these parts, I wasn't thinking about, you know. All right, all right. We wasn't thinking about that at first. So um when I was crafting this, I was cutting away at it. I was making it thin. I was making it sleek. Trying to get as thin as I can get it, and open up as much space as I needed to make sure that everything would fit down in here right. But I took away so much that I didn't need to take away, and that cost me the ability to have a sturdy part here. So we just go in circles when this happens. We end up printing more parts and more parts, and uninstalling and installing. It just becomes a part of the swing. Um, but as I go on and as I continue to do this, it gets better for me. Um, I start to get a little smarter about how I'm designing, and then um, the things that I'm looking at, or the things that I'm considering as I design, is getting a lot better because I'm thinking about how it's gonna lay on the bed as well when it's printing. How is it gonna print, and how are those layers going to hold together? Which I'm printing this in this orientation right here to sit flat like this. By me printing it flat this way, the layers are stacking up. So when the bolt goes through the holes, it's going to sandwich those layers together. That was the goal, to design it to where the sandwiching of the layers would happen rather than the um, if I printed it in this orientation here, I would be worried about those layers separating along the line with the bolt. And so these are like things that sometimes we don't think about when we're designing. We just go with a something that looks cool, and it's logically functional. But when you start thinking about like how that part is going to get created, then you have to think a little harder because it's not injection molded. And it would be a lot better if this was an injection molded product, I wouldn't have to focus so hard on uh, certain areas being flat, so I can print it to the bed and it will be a nice fit. But so yeah, we want that bed to make contact with a good amount of it, so that when we're doing a print, it doesn't come off the bed or do something crazy. I mean, you guys can see how fast that head is moving over there. Um, but yeah, if we don't pay attention to that type of stuff, we end up having to go back and redo it over and over until it gets right. But this part here, man, I'm satisfied with how sturdy this part is. I didn't know what to expect when I designed it. I designed it a little thick. I designed it on a point three, 0.32 inches thickness. It's kind of like what I went with as far as having this thing to sit flush and um, sit on top of the chassis. And it's got some girth to it, you know. It's got a little sturdiness, and it actually adds some sturdiness to the chassis. The chassis could be a little flimsy as well, like if you don't put enough parts on it to keep it squared. Um, you can find that, like if you're playing with this thing in the heat, or you're playing with it over or a duration of time, that the heat from the motor and the servos and stuff like that start to heat up the plastic a little bit, and it'll start to deform on you a little bit. It'll start to give way, and we're just trying to make it durable enough to withstand that type of activity, but also make it to where it's not so heavy that it can't bounce, or that it's so heavy that it can't hop when we get to that phase of making this thing into a hopper. Right now it's just a dancer. It'll dance, it'll do its thing, but we want this thing to hop. You know, once I get it to hop, mission accomplished. But it's got to start. It starts with that idea, you know. It starts with that small idea, and it'll go from there. It's been spiraling out. Um, where to have the most weight at is in the back. If we are going to make this thing hop, is to put everything in the back, or put as much weight in the back as we can, and you know, having sturdy parts like this kind of add that weight, even though it's a good part to add structure in the front and to maintain the sturdiness. Um, we have to match that in the back so that when we're hitting those switches, this thing is well balanced. So I have, for the next segment, we're gonna be working on this right here. This was the this is a spinoff from the first bracket I used. This is the first bracket that I created for the ESC, um, which was it was a good for a temporary fit, and it mounted right under the rear servos at first. This is before the servos sat really high in the back, like that portion there sat super high. Um, let me see, pinch up here. Yeah, so those servos, these sat up really high. They were upright at first. They were sitting upright, and so the new design was to lay them flat so that I can lay the body of the lower down onto the chassis. So with that out of the way, from sitting up there, I was able to get the body to lay lower. This all of the rest of this just misses the back window on the body, um, which was all a part of that challenge with dealing with those with the older version of vehicles, with having that small cab space. But this, um, I'm not able to use this anymore. But so what I'm gonna do is to spin off from this, which would be to take this portion here, which you see on the screen, take that portion, and then add to where I need to put holes to mount it, and we'll have that thing mounted up under here somewhere. I want it to tuck away nicely. I don't want it to have a lot of rattle or make a lot of noise too. So I'm trying to figure out the best way to put this to where once I start securing it down, all the wires have a place to live, which is one of the most important things um, as far as getting this mounted in as well, is making sure that it sits in there and it's not just gonna be you know it's not gonna be a part that's just throwing the whole build off balance. When I had it mounted off to the side here. I had it mounted off to the side, and you can see. Let me open this up more. You can see how much of this side is leaning over. You know what I'm saying? Like, to have it that far off to the side added so much weight to this side of the vehicle. And so when I would be hitting the switches, I could actually see the drag happening on this side of the vehicle. But this was a temporary fix, you know. I knew that I'll eventually end up moving it. I just wanted to figure out the steering area and see where I wanted all that at first. And now that that's done, we can tuck this thing away, and it's gonna be in the line inside of the wheels. Um, the main thing is inside of the wheel well. It's not hanging outside of the chassis to where that weight is gonna pull to any one direction. But we're working it. We're working it, and it's getting to be it's getting to be a fun project. When I first started it, it wasn't much of a it wasn't much of a fun. It wasn't as much fun as it is that I was just trying to figure out how I was gonna make everything work. Yeah, yeah. Oh, nice. She did win. She King Boo. Maybe you thought she was losing the whole time, but she was winning. Yeah. So as we look at this, I started to do some measurements for this, and I end up taking the back seat on it after I saw the time was starting to get late, and I wanted to start a live for you guys, and you know, get a little bit of this completed, because I didn't want to work on it without you all getting to see some of the visual of what I was doing, so you kind of understand how you're gonna be doing it and the direction you're gonna have to take things. Yeah. All right, so that thing is still working over there, still doing this thing. Not You might have won a trophy. You did your thing. So now we was just getting busting on the idea of what's going on with these connectors and why they don't fit, and what are some options I can do as far as creating a really smooth finish for this whole thing, not just have this thing looking wild and crazy. Because whoever soldered these, they hit this thing with a lot of heat, and when they heat it, they heat it with the solder. The solder went all the way down through the jacket here, and you can feel it. Like all of this is solder from where this is bending at all the way to the tip. That's all full of solder. So I don't know if the manufacturer did this on purpose, or if whoever the person was that was soldering this was new to soldering, and yeah, they really cooked this and took it back. I mean, all of this is solid until we get halfway. Then I get a little bend right here, but I don't know what's up with that, and it kind of makes me want to redo it myself and resolder this thing and get it to where these wires are pliable and don't look like they're gonna melt apart on me. But they put quite a bit of heat in there. Um, and I got some fittings that are not like RC style fittings. Like I got press fittings like this where I can just clamp them. I don't really want to do that with this. I want this to be like a quick connect where I can take it apart if I want to take it apart and redesign things. Um, so for this mount, the idea was to the first idea was to just zip tie it down um into the tray, right? That was the first idea, was to zip tie it down. And then my engineering side says you're much better than that. I don't know if you all ever feel that way, like where you get designing something or you're working on something and you get to a point where you just want to be done and finished with it, and you start shortcutting and you start thinking about, yeah, I could just throw some zip ties on there, but it's something inside of you that just like that just knows you need to do better, and it's just nudging you like, hey man, you cannot put zip ties on this. Like you have to find a place for this thing to be and find a unique way for it to snap into place or do something that will make this thing worth having, right? And so I had just have that rolling in my mind every time I look at this piece. I want to stick it down with some double-sided sticky tape or something. And then just in my mind I just keep getting that, man, you can design this thing better than that. Like don't have shortcut it, don't halfway do it with double-sided sticky tape or zip ties. Like if you don't design this piece. So I got to looking at it, and I think like what I'll do is I'll have one of these sides to lip over to where maybe this it's this side, to have it to curve over where it has to pass a groove, right? And that groove will snap it in, and it'll snap and secure into place, and that'll be enough to hold it in. That's the logic. So what has to happen is I have to go into the CAD software and actually design that in there. We can go in there and build that portion up, build this angle up here, and get it to where it's gonna snap and secure in that way. So right now, um, I see. I did a little bit of the design, right? Because I carved this area out so it sits down in there nice and snug. And then when it come around to the snapping in part, that's where I got lazy at. So now we just gotta create a tab of some sort that's going to reach up and and create that connection there. So we'll do that while we're waiting on that part to, yep, we'll go into drawing, switch it that way. This part is not centered in this thing at all, um, which kind of makes it kind of difficult to finding the center of things when the center of this is not centered. Let me see how I can make this centered. Let's see, what do I have to do? What do I have to do to get this thing centered? To move it first off. Or if any of you know how to move it centered, that would be awesome to get this thing to be centered. Let's say, man, I wish you all were talking in the chat so I can see some words here. Any of you are any of you familiar with Fusion 360? Yeah, anybody that's fluid or that know a little something about this software, let me know. I have to do a quick Google. How to get my parts centered. Sometimes I have the information, and some days I don't know where the information goes. So point to position. So it's selected and selected. Point is selected. Hold on, let's undo these real quick. So selection is there, and the point is here, and it doesn't give me. Maybe I need to create a center cross access on this thing to get it to do that. I guess I'll try eyeball it and center. Let's do this. We gotta find the center point of this thing. I got a better way. Get the measurements of the outside and divide that by 2. So we got 1.7. We'll just take it up to 1.7 divided by 2. 8 point 0.85. So we'll make this line, center line from here, 0.85. So that's the center point of that direction. Take this, and that we're at 2.25. 2.25 divided by 2 leaves us at 1. Center line. That leaves us. You're jittery on me. What's going on with this? All right. 1. 125 for that center spot right there. Oh, I went from the wrong spot. Do this
Want the trophy or not?
from the outside. 1.125. That's a little close to the center to me. All right. So now, getting this to line up on this on the green line and getting this to line up on the red line will put us on center. So let's get that done.
One more, probably.
Quick square here. We'll create a quick square based
Daddy,
on. Yep.
Trophy. Me too.
Based on that. Draw it over here. And this is just a long fix to something that is probably very simple to do. But it's gonna get the job done. All right, so let's pull that down and join it. This is a temporary part. This is just so that we can navigate that corner there. We can move this part and center it off. That's all we want to do. If I bring this thing around here, we just want to hit center point. We'll go to a move, the product now, go point to point. Zoom in. We're selecting that portion there. That point there to that center point. Out of the way so we can actually see the center point. Hold on, let's move this back. It's doing something weird right now. And I think it's just acting weird because I can't see the actual point I'm trying to link it to. All right, let's try this again. Get that point there and bring it to the center point. Come on. Why isn't it doing it? Type of things. These are the type of things that I struggle with in my design process. Sometimes I get it, right? I'll have it moving. Secure that right there. Now, there. Yeah, it's doing something weird. Maybe I need to draw something out right there too. Yep. All right, so not only that, create another drawing at the base here. Bring that over like that. Extrude it a little bit. One day I'm gonna figure that out though. I'm gonna figure out how to do that, and when I do figure it out, I'm gonna just lay it on y'all. I'm not gonna say nothing. I'm just gonna go and show how I do it. Y'all gonna notice. I'm gonna notice the progress. Wow. Now we can do point to point. Take that point and bounce it to that point. Yes, that's all we wanted. That's all we wanted. See how much I had to go through just to get to that point. Now we're totally centered out, right? X, Y, Z axis all in one, right? Now we can get rid of this. Go and chop that off and go in here. It took that much just to do one clip, just to do a simple clip that, go in here, get this started here. I want to design from this side here. Um, then we're right here with it. So now I gotta measure. I'll take my caliper, make sure I'm zeroed out, and I'm measuring where I think that clip is going to want to clamp onto the body.
Can I?
No, that's a stapler. No, the stapler is not for cutting. It's for sticking papers together. Okay, so 0.19, right? So 0.19 is how much we want to create a lip, or how far we want to go up before we create a lip. So let's get us we still got to create us a center line here though. So we create us a center line. Then create another center line based off of what's happening here. Hold on, let's undo that center line. The jitteriness of this is causing me to overshoot. But so from edge to edge, right? And then now we have our center point here. All right. So we got a center line there and a center line here. So now we can go in and create that latch. Take from the center. Say, how far do we want this clamp to be? Because I don't want to overdo it. 0.3. 0.3. Right, so we're at a 0.3. So down at the bottom, 0.3 for the length. And then that height is gonna be, it should lock in right with the edge of that corner there. Or just a 0.1. That's the thickness I went with. Well, hold on, 0.3 tab 0.1. That dimension there. Finish that to the side. Just that quick, I forgot how tall we were making it. So, not a problem to go back and measure it again. A 19, 0.19. So we extrude up 0.19, 0.19, right? So that portion of the tab, this is exactly where that lip would start to form. So we want a nudge to stick out of there. And then we'll do something cool off of the backside to where we can open it if we need to open it. So we'll add another 0.1 to the top of this, right? That's what I should have did in the beginning. 0.1. All right, so a 0.1. We come to this side. We're gonna measure down a 0.1 on a drawing scale. Here, from that corner there, 0.1 is the length. There. Now we're gonna pull this out. We're gonna pull it out and over. Let's say this doesn't have to come out that far at all. It's just enough to secure that edge. And the thing about like clamps like these, like if you go too far out, if you go too far in, it'll be hard to get the part out once you clip it in. So say maybe 0.5 or 0.6 would be ideal for a lip like this. So extrude that. Or 0.05 because 0.5 is way too big. Look at that. 0.05. That right there. And then this area here, we can chamfer it or make it into a fillet. I think maybe a fillet would look really nice or really cool. Let's go with a chamfer. So if we chamfer it, then we can kind of tailor it in. Okay. Thing right there. What up, Dre?
He's still doing live.
Mm-hmm. Because I'm over here calculating. Calculating some angles. There. This little lip I'm creating, this is just so that we can pull that tab if we need to pull that tab to get it to come loose. This just gives us a little space to grab that tab if we need to unlatch it. Also, maybe if we want, we can chamfer that part too. What you pressing?
This.
Why you want to waste staples? What we wasting? There, round it off. Obviously, this part is small, and it looks big because we're on this CAD software, but like a point zero 0.01 is like super small. Like it's like almost paper thin. See, like that nudge is not gonna make a difference. So like when I'm calculating these numbers, man, I'm like really in my mind trying to figure out like what's a good way to structure this thing so that it it really holds, like it has a firm grip. It's not just really cheap and flimsy. Yeah, that way, and it's just a bump. That's all we need to do is just for it to snap in place. It doesn't have to do anything other than that. Come on this side here. We can draw in some fillets on either side of this to give that some structure too. Give it like a 1.1. All right. So we have that little latch done. Uh-oh. It sounds like we got a complete product over there. We can go and jump over to that. All right. So we'll hang up on this and we'll come back to this tomorrow. Save it. Get back over here. See, our product has completed. And we can go ahead and bust this down and put that new thing in there and see how sturdy, test how sturdy the steering mechanism is, or the steering bracket is that we've just created today. Let's let that machine cool down. That thing is that bed is at 100 degrees right now, and it holds on to the parts surprisingly well when it's up at those temperatures. But once it cools down, it's like it releases the product. Like it releases it so nicely. And this is how simple I designed this thing to come apart. Um, I wanted every bit of this thing to be customizable when I started designing it. I didn't want there to be any reason why you couldn't decide on whether you wanted to create your own diff or use a different diff, you know. And then the servos. Servo mount there. I don't know what happened to this side that caused this to be so in there, but that one was in there. Maybe it's the plastic. As I was saying before I started using the press, the heat inserts, I had I was screwing the screws into the plastic, and with all the taking the screws out and putting them back in, it was chewing away at the plastic, and the plastic was actually melting due to me using a drill, and it was attaching itself to the screws. So now some of the screws got plastic reinforcement on them. All right, so I had double-sided sticky tape on these, which I gotta take these out now because I want to save them. Maybe I can get them to pop out this way, or I can just drill in from the backside and yank them out that way. Let's see here. Jump right through it. That bed is still holding on to this part pretty tight. We got our part. See how well that support did. Sometimes it looks really ugly, depending on the type of support structure that you decide to go with. Um, it can make it look cool sometimes, or it can make it look really crappy. But this isn't actually bad considering that I was showing you all the difference in having the support to be the same direction with the first layer lines rather than having them be separated. It's better to have them separated, but sometimes you end up with a weird looking patterns. There, this is pretty beefed up. You have to pop out the insert or the port for the in the holes. So that portion did well. I'm happy with the way that the support handled it. So That's what it looks like. You can actually see those lines, what I was talking about from the supports. Now, depending on how you calibrate your machine, you can have it to where these lines are not showing at all, and it will look smooth and you'll have a nice finish. But it just depends on how you calibrate your machine, and if you got the time to tinker around with it to figure out what's the best height for your layer lines and all that stuff for your supports. With all of the supports, I don't do very many prints that need support, so when I do a support, I do try something different to see how it will respond to my part. That's kind of how I've been doing these. Um, Let me open this up a little more. So we'll get this installed. It's kind of plug and play because I already had the dimensions of everything else. It's just a matter of getting it all mounted and together and figuring out what the right screw is. So for the screw, that is a little too short for what we want to do. We want this thing to screw all the way through our nut there. So we're probably looking at like a 25, a M25. Let me see if I have something like that. I got M30. 30s might work. I think that was an M25. Let's see. M25. Yes, that's the one. I knew that. See, I haven't been doing this that long, and so when I make a guess like that, it makes me happy. It makes me happy because I'm grasping these mechanics, this engineering knowledge without, any proper training on it. So it just makes me feel good to make a guess like that and to be on it. But then the new servo or the new mount goes into the servos. That it's like the more parts that you add into the structure, the stronger it becomes. But when you're printing these parts one by one, it seemed like they're gonna be flimsy and like you're gonna end up with some issues with them. But once you get them together and you actually see how sturdy they are together as one unit, you're like, okay, this is gonna work. Yeah, and this was the one that was binding up on us. So it had to have been the screw that was causing it to bite in deep like that. So we have that one. Now we'll attach our frame. Had here we just had random screws setting just to get this thing secured enough to do some other stuff with it. like I said, eventually with the last design is going to be the chassis, and that's this part that I'm screwing all of this into. Right now, it's just screws biting into the plastic, but when we design that part, it's going to have all of the inserts, and this is all going to be metal on metal. So I'm looking forward to that. Looking forward to that day. Now this is sturdy already, and haven't even installed it yet. Now we have to let's extend this out so we can really see what's going on underneath. These I like to get them finger started so I don't misthread them. I hate the idea of having to take the inserts out because I strip them or something because they not threading right. So I'll get that threaded first, and then I'll jump on it with the drill. All right. Now we do not see any flex happening now, and that's what it should have been like in the beginning. There should have been no flex from this thing here, unless we like really, really pushing on it. But no, that right there is where it needs to be. Let's boot it up and let's see how it's responding again. So it's steering a lot better already. That's what we were looking for. We got full range motion. None of the screws are binding up on any of the other screws. This is the ride height. No binding going on there. And this is fully extended. On one of these sides is, yeah, lotion? Which lotion? Which lotion? That's the men's cologne lotion. Get some lotion from the other side. Get the one in the white bottle. You don't want to be smelling like a man. Plus, it can make your skin irritated. It might make you irritated on your skin. So, ask mommy for the other stuff that could obstruct the steering, or that could be pulling against the steering. Oh, it's doing that thing again. I'm dropping frames. Come on. What's happening here? All right, I think we back in here. Man, I was getting some crazy buffering going on. We got some intermittent problems happening here. Right when we get to the meat of it and what's going on here. So what I was trying to implement and show y'all was the wheels all the way down at the bottom. We have our steering is perfect. Like there's nothing going on with it. No binding. This is our ride height. Still no binding. Everything's lining up the way it should. And this is our fully extended height. No binding. So we accomplished what we set out to accomplish. There's no towing going on as far as having it at any of these levels. This thing is gonna ride straight. So we succeeded, y'all. Well, I'm happy. Well, we got what we came for. That's what we came for. Yay. Where we wanted to be. All right. So we will end on this note. We came and we accomplished what we set out to accomplish. It took a little longer to get this done because of this bracket here being so not together. Uh, but we made it happen. It's where it needs to be. And that's what's happening. Is where it need to be. Thank y'all for coming and chilling out with me and relaxing with me today. I'm gonna go and tend to the kids and see what they need before bedtime really happened. And we'll be back at it tomorrow. Tomorrow we're gonna be jumping into what we're gonna be doing with this bugger here. All right, we're gonna find a place for that. We're gonna design the part, which we already started a little bit of the design, but we are going to print that part out, get it installed, and then we'll be looking at some different. We'll be playing around with some different ideas as far as the uh, the box back here for the batteries. I'm pretty satisfied with the way this is already, but I may want to look into some other ways that I could um, take away the height of this battery case and make it, I don't know, make it sit a little better. But we'll see when that comes. But thank y'all. I'll see y'all next time.